Hi. So this is a machine learning plus a web development project where, as the name suggests, we are going to build a model that is going to predict the quality of clothes, and that model is then going to be used by a web application, right? So let's first understand what are we going to do in this project itself. So what are we doing? Now, product size recommendation and fit prediction are critical in order to improve customers' shopping experiences and to reduce return rates, right? So, these data sets obtained from ModCloth and Rent the Runway could be used to address the challenges in catalog size recommendation problems. So, these data set means that there is a data set that is being created using the data of, I would say, about clothes, about users who are buying those clothes, sizes, and etc. Right? Though we will not be using the dataset for size recommendations, but to predict the quality of the cloth. Right? The reason being, from this perspective, we get to see that sometimes even hyperparameter tuning might not increase the predictive power of the model. But as a supplementary project, you can do the predictions for size fit too. Now, later on, you might get a better understanding of what size fit is, how is that data filled, is that data in string format or in numbers, right? So that you will be able to see later on. First, let's see the details of the project. Now, the project is divided into three parts. The first part is building a machine learning model to predict the quality of the cloth. Now the range for quality is from 1 to 5, and 5 being the highest or like the best quality. Next, we build a web application on Django to mount the prediction model. And last, we deploy the Django project on Heroku through GitHub. So the first part, that is the machine learning model. So we start off with building a machine learning model. We use a random forest classifier model and train that model using clothes dataset. There's abundant information in the dataset, like the size of the cloth or the size of the shoe, right? The size of the person buying, size means like waist size and all, height, and fitting information about the cloth itself also. In this particular project, as a dataset, in this particular project, like the project has a dataset that is not well prepared. So for that, we will have to thoroughly clean the data first. Now later on in the project, you will be able to see that the data has a lot of nan values or null values. So we will have to either impede them or impute them or directly remove them, and then we can go forward. So this is the second part of the project where we will build the web application using the framework Django. We will mount the model we built in the previous part on the Django project here. So this will be the last part, that is where we are going to deploy the Django application on Heroku using the connections to GitHub. Now let's move forward and start off with the first part, that is building the machine learning model. Hi, so this is a machine learning project where we will be building a model for prediction of the quality of cloth. So let's move forward and see what the first block entails. So the first block here is to mount the drive folder onto this collab notebook, meaning now we can access the files stored in our drive folders from this collab notebook. And even here you can see that the path for the directory is present here, that states content, and inside the content directory we have the drive directory, which stores all of my important files or the dataset itself. So next, as you can see, the next block is telling us about importing necessary libraries. Now, these are necessary libraries, but this is not the complete list of all the libraries that I'm going to use in this project. These libraries are only for data manipulation, data handling, or data visualization. Right. So the first library is NumPy. It is a library consisting of multi-dimensional array objects and a collection of routines for processing those libraries or those arrays. Sorry. Using NumPy, mathematical and logical operations on arrays can be performed easily and efficiently. Now we are using references where NumPy is actually now denoted by NP. Next you can see is the pandas library. It is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. Right. So as you can see, the last two libraries are the Seaborn library and the Matplotlib library. Both of these libraries are used for mainly data visualization, like building graphs on data and summarizing, inferring from those graphs. Right. So while Seaborn is a library for making statistical graphics in Python, similar to Matplotlib, Seaborn actually helps in exploration of your data by providing you with much more enriched color palette and much more graphs also, right, as compared to Matplotlib. So here you can see that I'm using the read JSON function of the pandas library, again because this is actually the JSON file storing all the data. And then you can see that I'm using the the head function on the cloth variable, right? So the head function prints the first 5 data points of your data set, and here you can see that the first 5 data points are printed or showcased. Here you can see the item ID, waist, size, quality, cup size, hips, like the sizes for women actually, and then the categories, and then height, username, length. And here you can see that there are a lot of none values, like shoe sizes has none values, shoe width has so many none values. So this is what I was talking about, that this data set was not really well prepared and has a lot of null values present inside it. Even here you can see the waist is not given, has null values. That is what I would want to say, right? So as a reminder, we are predicting the quality of the garment or the quality of the cloth and not the size. Here you can see the size. Yeah, the size is what it was actually trying to determine using this data set. And as a supplementary, even you can try to determine this or predict this rather than quality. Next, you can see in quality, we have 1 to 5 ratings, and a lot of ratings are actually 5, and there are very less ratings that are actually 1. So we can say that on this side at least, there are a lot of good cloth that users are buying and also liking, right? So next we are using the shape parameter to understand more about our data set, and it gives you a value of number of rows and number of columns. So we have 82,790 rows and 18 columns, from which one is our target variable or what we are predicting. Next is the isNull and the sum function, right? So isNull is a function that works on each and every data point and sees if there is any null value present inside your data point or not. And the sum function summate, I would say, takes a summation of all the null values that are present. Meaning what happens is that for one column, let's say item ID, isNull is trying to find out how many null values, if a null value is present or not, and sum is trying to summate that how many null values are actually present. So isNull function actually only returns true or false, true when a null value is actually present, and this sum function sums up the number of time true values were returned by the isNull function, and this is happening for each and every row inside the plot dataset, and then each and every column also, right? So you can here see that there is 79,000, like nearly 80,000 null values for waste, and 6,255 for cup size, 6,000, actually 26,726 for hips, yeah, and shoe size, shoe weight, and so on, right? So there are a lot of null values present. Now we don't know the reason for that, but we can say that this data set is not really great. So what we have to do is either try to fill up the null values or try to remove all the null values, right? So what I'm doing is first removing those columns that have a very large number of null values. And as you can see, I am removing waste. Again, it has like 80,000 null values and our data set consists of 82,000, right? So in that way, waste is not going to give us much information, and the reason why we are removing that. And then item ID again we are removing because this is not really giving out much information about the quality of the cloth exactly, right? So we are also removing that. Right, so after removing that, we're also dropping the columns having large number of null values or non values, and again not exactly provides much information or can't be processed like review text. Now this is going to be a string text. We are not actually handling our or making a model for NLP, right, natural language processing. So we're not going to use the review text to understand or correlate that with the quality of the cloth. So we are removing review test and review summary. Right, we are again removing username and user ID because both of them are not going to provide us with much information or might help the model in training, right? So next you can see the drop NA function. Before we were using only the drop function, which is used for mainly removing columns directly. And here we can even remove rows also by inputting a parameter that is an expression. But here this drop NA function exactly deals with null values. And if we are giving a parameter of any in how, that means that if in the data point, if there is any null value present inside any column of that data point or of that row, we are going to remove that row itself. Meaning, as you can see, the first two rows both have null values in shoe size, shoe width, right? And even in this, the second row, there is a null value in bust. That means we are going to remove this row, right? And again we are going to remove this row also. But for example, let's say that this row had no null values in any of the columns, then that row will stay with the dataset itself. So now you can see that from 82,000 we are down to 7,000, like not even 110, right? And again, this will have no null values now because we have used the drop NA function. So next what we are trying to do is find categorical data, right? So in the next video, I'm going to showcase why categorical data is important and how to convert categorical data into numerical data so that we can actually feed that data into the model. Again, start off with the categorical data type and why they are important. Now, there are many columns and there are very different type of data sets also inside which the set different columns actually have only a set numbers of values and they are reoccurring in them. As you can see here also, for the cup size column, you can see the cup size is C, D, B, DD, that is also E, and triple D again F, and so on, which again you can see that for the cup size C, it has occurred 1600 times inside my data set, right? So this is what I call categorical data, that there are set number of values inside your column and they are reoccurring different number of times inside that column. So using the value counts function, right? If I use that function on a column, it provides me with a dictionary which stores the unique values inside that data and the number of times they have occurred, right? So for different categories or for different unique values and the number of times they have occurred. So this is categorical data, and now on to the reason why they are important, because they store information and if extracted properly, it really helps the model in understanding and generalizing on the data, which again increases the prediction quality or the predictive power of the model itself, right? So this is why handling categorical data is so important. Next category, that is like the like the category and categorical data, right? So again, category has new, tops, bottom, dresses. So from here to here, all of these are the unique values inside this category column and the number of times they have occurred, right? So using value counts, you can easily find out if a column has a unique, or I would say if a column is a categorical data column or not, and if it is, then what are the categories inside that column. Next is the length. Again, length might be misleading in the sense that there might be a numerical value, right? Like 20 centimeters, 15 centimeters, and so on. But here you can see that it is actually a string value, again, a categorical data type or data column having 1, 2, 3, 4, 5 categories, each occurring this number of time. But here you can see that unlike the above category or categorical columns, this one has a category which is occurring for 5,000 times. Now our data set is shrink to 7k data points, right? And from which 5k data points just have just right length in the just right value in the length column, right? And very short has only 50. Again, 50 values in 7k values is really small number. Next is the fit, which states that if the cloth was fit large or small in respect to the user itself, right? Again, a categorical data column. So here we can see that we are trying to convert the categorical data column or data type, and we are doing that using the label encoder function. Now we are calling the label encoder class, like instantiating it, and then using its fit and transform function. Now what happens is that once called upon the fit function, what happens is we are going to feed our information, or I would say the data, to the fit function. Then it understands that, yeah, so this is the data set, or I would say a part of the data set. So it identifies the categories and how much importance is to be given to each category inside that column, right? Once it has determined that in the fit function, what happens is that transformation happens, meaning that string data is now converted to numerical data using the transform function, right? So what I'm doing is building a list of columns that I want to transform from categorical to numerical data, and then using a simple for loop I am transforming the data. As you can see, what happens is that first the cup size column is transformed, and it is going to transform the data like so. As you can see, A, then double A, then B, C. Now this is not exactly in the increasing or decreasing order of the size, but what happens is that label encoder understands that, yeah, A is to be given priority, then A, then B, then C, and then so on. So this is going to be transformed as 0, then 1, 2, 3, right? And then so on. Similarly for rest of the columns also, bottoms is going to be stated as 0, right, in the numerical value, and then 1, then 2, and so on. So even here you can see that category is determined as 2. So 2 would be 0, 1, and 2, new, right? And the cup size is now again determined as 3, 6, and again 3. 3 would be 0, 1, 2, 3, a C cup, right? So with that, we were able to first understand which column were having categorical data, and then we were able to convert that categorical data into numerical one, right? So once the data is converted to numerical data type, we can directly feed that data into the model. But again, before that, we have to clean the data a little. So with that, what I'm doing is, yeah, I'm making a copy of my data frame, right, into this. So what happens is that once made a copy, whatever changes I'm doing into this won't be occurring in this, right? Again, there is a shallow copy and a deep copy. You can learn about that or search about that, right? Next, by the way, a deep copy is happening here. Next, what I'm doing is creating a function so that I can use that function on my one of the columns. And how I'm doing that is with the help of map function. So what happens that there is a map function which can be run on any column or even on the whole data set, and takes a parameter or an argument that is again a function. Meaning, in the map function, you have to provide another function that is going to be implemented on each and every row of the column or the whole data set, right? So what I'm doing is I'm trying to use the ref1 function on each and every data inside the bust column, right? And what I'm doing is I'm first trying to find if my value inside the data is a none type or not. If it is not, what I'm trying to do is convert that into float type and return the float data. The reason being that this bust column is showcasing numbers but is actually in string format, meaning that 34 is actually inside quotes, that is a string. So I'm trying to convert that into my float data type. But what happens is that there is some values that are like having values like 34 or 36, 34 or 37, and so on. And some values are not even numbers exactly, but they are not null. So what I'm doing is trying to remove them, because what happens is that if I'm trying to convert x into a float data type, but x stores that a string that is, let's say, happy, then again happy can't be converted into a number, right? So with that, what I'm trying to do is, if it can't be converted into float, that means that there is no number present inside the x part or inside that data point. So return np_nan or 0, right? So here you can even see that once transforming the data, I can see that there is one null value present inside my bust column, meaning that this column had one value which couldn't be changed, or I would say transformed into the float data type. So again, using the drop NA, I'm dropping that one data point, right? So now I have 6,999 data points with me, right? So next what I'm trying to do is extract data from the height column. As you can see, again, this is in string, not in any numerical data type. What I'm trying to do is extract the height, right? And what I'm doing is trying to convert this feet and inches into inches. So what I'm doing is, first I'm trying to, yeah, this was just an experimentary part to find if I'm able to do that or not. And even here you can see 5 feet 1 inch is actually able to, or I would say I'm able to extract 5 and 1, right? Later on you will understand what I'm going to do with this 5 and 1. But here you can see that I'm importing the array library, again used for regex manipulation. And what I'm trying to do is, now this is a regex expression which is telling that you have to find numbers inside strings, right? As you can see, this string has 5 and 1. So we are trying to extract 5 and 1. So this regex expression is telling that you have to find numbers that I would say that a string can have a number start, or I would say that a number is starting the string, a string is ended with the number, a number is in between the string, right? These three cases can happen. So these three cases are actually handled here, right? And then using the regex expression onto my list, I'm trying to catch, or I would say find all the numbers, and then I'm storing that number in my list and then printing the numbers. So this is now going to happen on a larger scale onto the height column. As you can see, I have taken the height column and stored that into a list using the toList function. Then running the extracting function onto each and every value inside the height list, right? And then storing the result into my updated list, and then storing that list into a new column inside my data set, right? So again, here you can see what is happening is actually that I am converting the feet and inches into inch, right? Here you can see if the length of number is 2, why 2? Because this numbers list is actually storing my this 5 one that I was able to extract from the string itself, right? So I am storing that those two numbers, right? So if there are two numbers, that means that number 0 or the first number would be the feet number, right? 5 feet 1. So I'm now multiplying with that with 12 and then adding the second number that I get, because again this would be in inches only. But if there's only one number, then the probability is that there's going to be a 5 feet only, no inches, like no value for inches. So again, only multiplying that with 12. And if there is no, if the number is actually an empty list, that means that there was no value inside my height column, which tells me that there was null value. So I'm just returning a null value, right? Now for, yeah, using a for function on the height list, not exactly a function, but on a height list, using extract size on the height, I was able to extract information and then convert that into inches and then return back, or I would say store that value into my updated column. Lastly, I've just created a new column through the updated list. And now here you can see that the height inches is now storing the numerical values of heights in inches, right? 5 feet 1, 61 inches, and so on. Again, for validation, I was looking if there was any null value present. Unfortunately, there was not, right? Height inches does not have any null values. Next is box plot, right? So box plot is exactly like here. What happens is that boxplot tries to find outliers in your data. Actually, boxplot is used for finding outliers in your data. And here these dots, as you can see, are considered to be outliers. So it takes in your data, finds means, finds quartile ranges, and then understands which value might be considered as an outlier for this data set, right? So for my size column, you can see that values above 30, actually values above 27, 28, which is represented by this line, is considered to be outlier, or values below 0, or this line, right, represented by this line, is considered to be outlier. So in this data set, the column size is actually having some outliers, which again should be removed unless we are actually building a model to predict outliers or doing outlier analysis. We should remove these outliers. Next, we have the height inches, and as you can see, again we have an outlier, and this outlier is pretty far apart as compared to the minimum value this dataset should be having, right? So this outlier again will disrupt, or I would say will actually derail your model and bring down the accuracy of your model. So if your dataset is having outliers in this sort or in this manner, you should certainly be removing the values, right? And that is what I have done here also. Though I have commented them out later on, because you what you can do is actually try to use different combinations of outlier removals and see how they are actually impacting your model by looking at the training and testing data, right? What you can do is maybe uncomment these two and then run your model, then later on uncomment these two, then run your model. So you will able to see how outliers are impacting your model and its accuracy. So this is the heat map, that is a heat map of a correlational graph that is built using the core function onto your data frame, right? SNS again is the Seaborn library, and you can see the color palette, right? So what is that we are trying to do? Here we are trying to build a correlational graph which is going to give you a measure of how correlated one column is to another. And when I say correlated, I mean how much influence one column, I would say, right, yeah, this is not the perfect way to phrase that, but I would say how much influential is one column to the other, and if there is going to be a change in one column, what is then going to happen inside the other column, right? So in correlation, what happens is that if there's, let's say, column A and B, and they are highly correlated or positively correlated, what happens is that if there's going to be change in column A, then there's going to be a change in column B also, a positive change. Meaning, let's say that there's two columns, size and height. If there's going to be a change in size, let's say size is increasing, then the height is also going to increase, right? Now, this is, I'm not generalizing, but I'm saying that to explain what correlation means. Next, as you can see, the numbers ranges actually from 1 to -1, when the range is -2 for this data set. But in general, correlation actually ranges between -1 to 1, both inclusive. And 1 means that the column A, let's say, is highly or perfectly correlated to column B. Meaning, if there's going to be a change in column A, then an equivalent change is going to happen in column B too. And a -1 means that an inversely equivalent change is going to happen, right? So with this, why are we actually plotting that? The reason being, what I'm trying to find is, let's say, yeah, the quality, right? We are trying to predict the quality of the cloth, and there are numbers which are representing how much influential each of these columns are onto the quality column, right? But as you can see, the numbers are very small or are very close to zero, meaning that all of these columns are not really influential to the quality column. Again, this already gives you a premonition that this data set has columns which are not really, or I would say, which are not really going to help your model predict the quality column, because there's no column that is influential to your quality column, right? I can see the highest value being, if I'm taking the absolute value, 0.21, which is of the fit, right? Except that there is no column that has a high influential power onto the quality column, right? And even later on, you will be able to see that when we are actually training our model. So now I'm just bifurcating my data set into my training data and my finally trained, or not trained, but target variable. Now I'm actually importing my libraries that are going to be used for training and testing the data, right? So using the train test split function, I'm going to split the data as my training and testing data. Since the test size is 0.2, again this means that 20% will be test data, rest would be the training data. Random state, if the random state is a non-zero number, that means that we are going to shuffle the data first, then segregate the data into training and testing data. Then I'm instantiating the random forest classifier model, which has 250 n estimators and a parameter n jobs is equal to -1, which again means that it is telling your processor to use all of its processors to train the model. Then I'm using the fit function on the train and test data, and you can see that the accuracy is 95%, like reaching 96, which is very high. But when you actually train your model or actually test your model, sorry, if you test your model on the testing data set, you can see the accuracy is only 43, which is like not even half. This means that this model is heavily overfitting on the data set. And to maybe fix that, you can maybe uncomplex your model, right? Use less estimators or try to hyperparameter tune your model, right? But again, the main reason why we are having a low testing data, like, can be actually blamed on, right? Can be actually blamed on, first, the data set was not prepared properly. Second, we are trying to predict the quality, but the dataset was actually made to predict the size, right? And the third reason, which is like the most important reason, is that inside our correlational graph, you can see that the quality column is not actually being affected or influenced by any other column to a very large extent. And that is the major reason why, even after training on random forest classifier model, which is a very strong model, we are getting a low accuracy, right? So this was the main reason why I actually took this data set, to showcase that sometimes even with the data set, you might not get high accuracy, because either your data set is not prepared in the way, or the thing that you're trying to predict is not exactly what your data set is trying to showcase. And second, that maybe the target variable that you have chosen is not actually being influenced by any other column inside your dataset itself. Right. Next, what I'm doing is basically, yeah, dumping the model. That means I'm storing the model so that later on I can directly call on this model and use its predict function, which is again going to be used inside your Django framework application, or the web application that we are going to build. So this is the second part of the project, where we are going to implement a web application using the Django framework. Now before moving forward, let's first understand what Django really is. So Django is a Python based free and open source web framework that follows the model template views architectural system, or pattern. Now, it is a web framework that has a set of components that helps you to develop websites faster and easier. Right? Now, it might not be really clear as to what model template views architectural system means, but basically in our application there's an entity that is called the front end, which is shown on the website. There's the backend that is working like behind the scenes, and then there's the database that in Django's perspective is called models, right? So we are going to use the front end and back end part and show you where each of them are being implemented. Again, in terms of Django, we are going to implement the templates and views architectural system, right? Now moving to the code part. So first we are going to set up the code, right? So first we are going to create a project directory inside which you are going to store your code. Next, we are going to build an environment for that project, right, in the directory. And to build an environment, if you're going to, or I am going to say, if you're using a PyCharm IDE, right, like myself, what you have to do is go to Files, click on Settings, and inside your settings, go to Project. There would be a name, right, for the project. Then click on Project Interpreter. Once you click on that, now it might show you a interpreter that you might have created before or an environment that you might have created before. But if you want to build a new one, click on settings or the button that shows the settings tab. Click on add. Then type in the name of your environment and where you want to store that environment. Then use the Python version that you want to use for this environment and then click on OK. Right? I have already created the environment that is named clothes using the version Python or 3.7. Right? So the next thing that you have to do is go inside the directory in your terminal, and in the directory, wait, yeah, sorry. So what you have to do first is that go to your terminal, go inside the my site directory, right? Now the code has a my site directory, and inside that another my site directory and a polls directory. So go inside your project, like for me this is clothes, then go inside the my site directory. Once inside that, what you have to do is run the command pip install r requirements.txt. So what happens is that requirements.txt stores all the information of the packages and their versions which are required by this project. So once you run this command, all of those requirements or packages and dependencies are going to be installed inside your directory environment, right? So once you have done that, what you have to do next is run the command python manage.py migrate. Now this is a command that is specific to Django, and this command is run to instantiate tables that you have created or Django wants to create so that you can run the project smoothly. Now Django provides you with the base project onto which you can build things to add on functionality for your website, right? You don't have to code in from scratch, and that is what I'm going to show you next, right? So first go to the settings.py file that is inside this my site directory here, right? And here you can see a lot of settings that are being showcased here. And the first thing that I would like you to see is the installed apps. Now, what happens is that you have a base project, then onto which you create new apps which brings functionality onto your websites, right? So the project has a project folder and a lot of apps, and inside project folder you have the settings file which handles how this website is going to work, and then there's a, I would say there is apps, or there are apps, yeah, there are apps which add on to the website to bring functionality on your website, right? And here you can see that there's this polls. Now wait a minute, yeah, this polls was created by me But all of these were created by Django itself when I called on the base project. And you can see that there are apps which are handling the sessions, the authentications, the admin part, right? So all of these are already pre-built. You don't have to build from scratch and you can directly use them. Next are the middlewares. Again, these middlewares are pre-built and are handling your security middleware, like security, handling your CSRF tokens, right? So all of these which are important are already being pre-built and given to you. Again, one reason why Django is very good for beginners in web development. Next, you can see that there is a column or there is a variable that is handling databases. You can connect your MySQL, PostgreSQL, or SQLite 3 databases to your project, right? So you can even handle your data, retrieve or store your data with the application itself. Last is the static files, right? Static files are CSS, JavaScript, and images. So what happens is that when deployed on the, I would say on the server, all of the static files are actually stored in one place. And to actually give information to the server that in which file these static files are to be stored, we set up the static URL and the static root variables. So static URL tells the server that onto this path you will be able to find the static files, and the static root determines that which directory would store the static files, right? So this is something which is not really beginner level stuff, but for more understanding, you can go to the docs and understand what static files really are and why there's a requirement of storing them in static files directly, separately, right? So with this, I'm going to move on to the polls, that is our app. And in the app, there are two things to see. First is the templates, that is my HTML file or the front end part, right? This HTML file. And as you can see, this HTML file is storing or showcasing a form, which is something that I'm asking the user to fill. And once this form is being filled, there is a submit button at last, right? This button. So once the user clicks on this button, all of that information is going to be stored into the backend first, right? So what happens is that this form is filled, the submit button is clicked, and all of that information then goes to the backend, which is the views.py, right? Views.py file inside my polls directory, right here. So as you can see, I'm storing all of that. Yeah, I'm storing all of that data into the variables here inside my index function. So what is happening is that I have created a function inside my views.py file, and that function is storing the values that I get from my form inside these variables. Then I'm using these variables to create a data frame. Then this data frame is loaded into my model that I stored in the last part, right? I'm calling that model, then using the predict function of that model to predict on the data of this data frame, right? Once I get the result, I send that result back to my front end using the context or simply response. So as you can see, this function has a render function as a return value. So render function helps in rendering your HTML page, right? And one function created here is specific to one HTML page, right? So this index function is now mapped to my HTML page. So whenever I want to go to my index.html page, this function starts to load and run. And once this function runs, It understands that there is going to be some data coming from the HTML page, and I've stored that data here inside these variables, which later on will be used to for prediction purposes to get the result. But as you can see, how is this function exactly running? Because we have just created the function, right? There is no function call here. So what exactly is happening is that we have a urls.py file. So what happens is that this index function call happens only when a user is going onto the set path. Now this is a little complex to understand, but what exactly happens is that there is a path defined, a URL path onto which if a user goes, then this function there's an automatic call for this index function. Then this function understands that I have to render the HTML page, right? So what happens is that let's say that we have a URL www.google.com. So once we go onto that path, this function index underscore func automatically runs. When this runs, it understands that I have to render the HTML page. So this function renders the HTML page, and then onto your screen you are able to see the HTML page. So this is exactly how it is working. And once the page is rendered, you fill up the form, you click on submit, all of that data comes again back to the backend. We get the prediction done, we get the result, and that result is again sent back to the front end. So let's see that how this is happening exactly. Right. So this is another command that is specific to Django, Python manage.py run server. So once you call this function, I would say once you run this command, the run server command, a local server starts to run onto your local machine, and it is providing you with a localhost URL. Click on this URL and you can see, yeah, you can see the form here, right? You can see the form here. So with this, we have completed the second part of the project where we were trying to build a web application. And in the third part, we are going to deploy this web application. So this is the third part of the project where we will be deploying our web application on Heroku. Before we start with Heroku, we have to use some files which are like commands for Heroku to understand. So let's start off with runtime.txt and procfile. Now runtime.txt is basically just telling Heroku which language or base is to be used by the server. While procfile here, as you can see, is the mechanism for declaring what commands are to be run by your application in Heroku platform and from where those commands are to be extracted. The commands that are specified in the last part, like run server and migrate, these commands are executed in Heroku server using the proc file so that the code can be set up onto the server successfully. Right. So both of these files are really important for deploying your project on Heroku. And even in runtime.txt, here you can see that we are trying to use the Python and the version of that Python. Next, what you have to do is go onto your GitHub account, create a new repository, and then upload your code onto that repository. Right? You can see here what I've done is created the repository named clothes, and here that repository now stores my code, and the code should be uploaded in the same exact order, meaning that your my site polls directory should be here with the flow and proc file and all of the other files. There should not be a folder inside which all of these files are present, because Heroku connects your repository to its app and access the folders likewise, right? So what happens is that if there's mismatch of folders, then your server onto your Heroku account won't be able to understand if the code is really present or not and will create problems later on, right? So once you have done this, right, once you have uploaded your code onto your repository, go to your Heroku account and yeah, log in into your Heroku account. If you haven't created a Heroku account, just click on sign up and create your account. It asks for some basic details, right? Your affiliations to any organization, if there is any, and basic details like your name and email ID, phone number, right? So once you have logged in into your account, you will be redirected to your personal dashboard from where you can click on new button here and click on create new app. Just type in the app name, choose a region. There's only two regions here. Then click on create app. Since I've already created an app, you can see that once created, your app will be showcased in your dashboard. And this was the app that I created. Right. So next you can see that the first thing that you will do is go to your settings. Inside settings, scroll down to build packs. Right. In build packs, click on add build pack. Click on Python. Then click on save changes. Once you do that, a Heroku Python build pack will be set for this account. Not exactly account, but for this app in this account. Right. So let's go on deploy. And now in deploy, you can see that there are three methods: Heroku Git, GitHub, and container registry. Click on the GitHub connect, right? This is the method that we are going to use. So click on this and then it will ask you to log in into your GitHub account using your credentials. So log in. Once you do that, your GitHub account is now connected to your Heroku account. The next thing that you have to do is search in the repository that you want to use. Since mine was clothes, so I searched clothes and then there was a connect button here. Click on connect button. So once connected, then your repository is connected to your app, right? And here you can see that connected to my username, my repository by my username, right? So this is where my repository is and this is my username, so it is now connecting my repository with this app. Lastly, scroll down to manual deploys. Now in manual deploys, choose the branch. Since I'm going to use the master branch because that is the branch that holds the code, so I'm going to choose the master branch, then click on deploy. Now once click on deploy, it is going to take some time because now your code is first being accessed from your GitHub account, then the code is getting set up onto your server so that later on you can use the server directly to host the website. As you can see, it has detected the Python app from the build pack. From the runtime.txt, it is now extracting which Python version is to be used. Later on, from my requirement.txt, it is installing all the requirements or the packages which is required by the project. Then it is running a command that is python manager.py collect static, which is amalgamating all the static files from all over the places to just one place. I would say accumulating all the static files from all the places to one place, that is my static files directory, right? So this is actually run with the help of our proc file. And lastly, when all of that is done, it compresses some of the files and releases or launches your server. So once the code is set up and the server is running, it is going to give you a views button here. Click on this and it would redirect you to your website. Now you can just click on the name and yeah, well, I don't wear a bra, but sure. Anyways, okay. I'm just inputting anything just to show you that once you submit your data goes to the backend and then prediction is done, then that result is again sent back to the front end. And you can see the quality is determined as 4. So a 4-star rating out of 5, which is pretty good, right? So with this, we can say that we have completed the third part of the course, or I would say the project also, right? Which was deploying your Django application on Heroku.